Hello everyone, welcome to the A's Data Science. I hope you are doing well in your life and academics too. Today we are going to do the graded assignment of Statistics-2 for Week 7. By doing this graded assignment, we will also learn the important concepts of Week 7 in Stats 2. X bar square. So without waste question. The first question basically says that a random sample of size 55 is collected from a normal population with mean of 100 and standard deviation of 5. Find the variance of the sample mean. So first of all, in this question we are provided with the mean of the distribution, which is 100, and the standard deviation of the distribution, which is 5, and the question basically asks about the variance of the sample mean. So the variance of the sample mean is given by the variance of the distribution divided by the number of element in the sample. So it will be going to be equal to sigma square by n. We have value of sigma and n as 5 and 55 respectively. If the value is different in your question, then you can put those value here. So the variance of sample mean is basically going to be equal to 25 by 55, which is 0.4545. Hence the variance of sample mean is 0.4545. Let's now see the second question. Question number 2 basically says that a fair dice is rolled 300 times and let x denotes the number of time we get a 6. Then we have to find a bound for the probability that x by 300 differ from 1 by 6 by less than 0.4. So first of all, let's assume x as a variable which follow the Bernoulli distribution, where the probability of success basically means getting a 6, hence the probability of success will be equal to 1 by 6. Now we need to find an upper bound such that the sample mean doesn't deviate more than 0.4 from the mean of the distribution. So as per the weak law of large number, the probability that the sample mean deviate more than a constant is less than or equal to variance of the distribution divided by number of elements in the sample into the constant square. So now first of all, let us find the variance of the distribution. Since it is a Bernoulli distribution, so the variance Bernoulli distribution is basically given by p into 1 p, so which is basically equal to 5 by 36 here. Now if we plug in all the required value to find the bound such that the sample mean does not deviate more than 0.4 from the mean of distribution, then it will be equal to 1 minus 5 by 1728, which is equal to 1723 by 1728, which is equal to the option number 1. Hence the option number 1 is the correct option for this question number 2. Now if in your question the constant values like the value of the mean, the deviation or the number of time we roll the dice is changed, then you can put the desirable values in the formula that I just described. You will get your answer, and you can check your answer by the fact that difference of denominator and numerator is 5, just because variance will be same in all case, just denominator will change, and if we minus it with 1, then absolute difference between numerator and denominator will be 5. Now let us see the question 3. Question number 3 basically says that x1 x2 till xn follow IIDX, where the expectation of x is given as 20 and variance of x is 4. And the pattern of sample variance is also given, which is basically the summation of I is equal 1 to 5 of xi minus sample mean to the whole square divided by 5. And we need to find the expected value of sample variance. So if we look at the denominator of the given pattern of the sample variance, it is n. When the denominator of sample variance is fully n, it means that the sample variance is biased. And the expectation of sample variance when it is biased is given by n minus 2 by n into variance of distribution. So here are given n is 5 and the variance is 4. If these values were differ in your question, then you can plug in those values too and solve them later to get the answer. So the expected value of sample variance after putting n is equal 5 and variance is equal to 4 is 16 by 5, which is 3.2. Hence the answer of question number 3 is 3.2. Now let us move forward to the question number 4. Question number 4 basically says that xi follow normal with the mean value as 0 and variance as 1 by I square, where I varies between 1 to 9 and all of them are independent. Y is defined as a new random variable where y is equal to summation of I into xi over I is equal to 1 to I is equal to 9. We need to find the variance of y. Since y is defined as summation of I into xi over I is equal to 1 to I is equal to 9, and we know that variance of constant into x is equal to constant square into variance of x. So here variance of y will be also equal to summation of I square into variance of xi over the I is equal to 1 to 9. And in the normal distribution, we are provided with the variance of xi, which is basically 1 by I square. So the variance of y will be now equal to summation of I square into 1 by I square over the I is equal to 1 to 9. I square and I square will cancel out each other, and variance of y will now only left with summation of 1 over I is equal to 1 to 9. Now since in summation we do not have any I variable, so this summation repeat over 9 times, but every time its value will be 1 only. Hence the variance of y will be basically 9 into 1, which is 9. Now let us see the question number 5. Question number 5 basically says that suppose x1, x2 till xn are NIID random variables with mean value equal to nu and variance equal to 16. Using Chebyshev's inequality, find the minimum value of n such that probability sample mean doesn't deviate more than 1 with mean of distribution with the bound greater than 0.9. Since the Chebyshev's inequality is equal the probability that sample mean deviate at least constant value from the mean of the distribution is less than or equal to the variance of the distribution divided by the number of elements in the sample into the constant square. So if we model this inequality in lesser than format, then it would be basically probability that sample mean deviate at most constant value from the mean of the distribution is greater than or equal to 1 minus variance of the distribution divided by the number of element in the sample into constant square. In the question we are already provided with upper bound, which is basically 0.9. So 1 minus variance of the distribution divided by the number of element in the sample into the constant square will be equal to 0.9. Later, if we plug in the values of variance and the constant and then try to solve for the number of element, then n is equal to 160. Hence the answer of question number 5 is 160. Let us now see the question number 6. So the question number 6 basically says that consider a sample from a Bernoulli distribution whose probability of success is 0.6, and we are asked to find the empirical distribution of this sample. So as we all know that the empirical distribution is a type of probability distribution that is derived from the observed data rather than the theoretical model, and here we are already provided with data or sample. So we're going to use the basic method to find the probability of something, which is basically the number of favorable data by total data. So the probability of 0 will be equal to 3 by 10, which is 0.3, and the probability of 1 is basically 7 by 10, which is 0.7. Hence the correct option resemble with our answer is option B. Hence the correct option for question number 6 is option B. Again, if the sample values differ in your question, then you can basically use the concept of number of favorable data by total data to calculate its probability. Now let us jump on the question number 7. Question number 7 is basically the continuation of question number 6, where we have to use the same sample of the Bernoulli distribution and we need to find the mean of the sample. So we know that mean, which also known as average, is equal to the sum of the data by the total number of element in the data, which will be here equal to 7 by 10, which is 0.7. Hence the mean of the sample is 0.7. Now let us see the question number 8. Question number 8 basically says that in a large population of student P, student prefer chips over cookies and 1 minus P student prefer cookies over chips. A survey was conducted among the 200 student and 120 preferred chips. Assume 200 sample as IID Bernoulli with P, where P is equal to sample mean. We need to find the variance of the sample mean. Question: it is given that each X follow Bernoulli distribution with P, where P is equal to 120 by 200, which is 0.6. So as we know that variance of sample mean is given by variance of distribution divided by n. Since X is here following the Bernoulli distribution and the variance in the Bernoulli distribution is given by P into 1 minus P, so the variance will be 0.6 into 0.4, which is 0.24. Now the sample mean will be equal to 0.24 divided by 200, which is basically 0.0012. Hence the answer of question number 8 is 0.0012. Now let us see the question number 9. Question number 9 basically says that x1, x2 till xn follow IID with uniform distribution over the range 4 to 10, and we are asked which of the following inequalities are true with respect to Chebyshev's inequality. So first of all, if we look in the all given option, then we can find that the deviation in the each option is 5 only, and 2 options are written in lesser than format and 2 options are written in greater than format. So here we basically have to find the bond that deviation of sample mean with mean is 5 in both format. So as we know, Chebyshev's inequality is equal to probability that the sample mean deviate at least constant time with the mean of the distribution is less than or equal to variance of the distribution divided by the number of element in the distribution into the constant square. So the variance in the uniform distribution is given by b minus a to the whole square divided by 12. So the variance here is equal to 36 by 12, which is 3. Now probability that sample mean deviate at least 5 with mean of distribution is less than or equal to 3 by 25 times n, which is equal to option 1. And the probability that sample mean deviate at most 5 with mean will be equal to 1 minus 3 by 25 times n, which is equal to option 3. Okay, so let us now see the last question. Question number 10, basically continuation of the question number 9, where have to find the minimum value of n such that the sample mean lies in interval 5 to 9 with probability more than 0.95. So first of all, if we calculate the mean value from the uniform distribution, then it will be equal to a plus b by 2, which is equal to 7. Now the given interval is 5 to 9 and the absolute difference between lower and higher value of this interval with mean is 2. So the constant of difference will be 2. And by using Chebyshev's inequality, we have to find the minimum value of n such that the sample mean does not deviate more than 2 from the mean of distribution, which is greater than 0.95. So 1 minus variance of x divided by n into constant square will be equal to 0.95. The reason why we have putted 1 minus variance of x divided by n into constant square is because the given bound is in the greater than form. So if we later plug in the required values and solve it, then the value of n is going to be equal to 16. Hence the answer of question number 10 is 16. So that is it for the graded assignment of week 7 for Stats 2. I hope you all learned something from my video. If you do, then don't forget to show us your love.